Pleasant morning to my dear lovable students. I hope you all are fine. In this conversation, we are going to continuation of concept from chapter number 1, especially the function. The name some elementary function. Okay, some elementary function. So in your book, page number, some elementary function is given clearly. So elementary function, page number 22. So first I am moving to identity function. What is the name? So identity function. So identity means so x, y, otherwise as per your book given ABC, isn't it? So this is called x, the domain means this is called the codomain y. So A, B, C means y also A, B, C. For example, so A is considered for A, comma, B, comma, C means what is the meaning of A into A? Definitely the pair of first pair A, comma, A means second pair A, comma, B. But in identity function means definitely B comma B will come at the same time C comma C also will come. For example, how to apply in the number? So A is equal to 1, 2 and 3 means, so A into A means definitely what's the value will come? 1 comma 1 is possible, 2 comma 2 is possible and 3 comma 3 also is possible. This is the term of identity. Why? Look at there, y is equal to x, isn't it? So x also y means 1 means y also 1 at the same time. X is equal to 3 means y also 3. So A related to A, at the same time B related to B, at the same time C related to C. If you make it in graph also, we will get it y is equal to x. Because x value 1 means y also value 1. Then x is equal to 2 means y also true. So here x is equal to minus 1 means x is equal to minus 1 means y also minus 1, just equating the pair. So this is called y is equal to n, y is equal to x. That's the main function name, identity function. I am moving to second name. What is the name is their second name? Actually constant function, isn't it? The continuation of your constant function is there. So I will write here, place is there, no? Constant function. So constant function, the term is there given clearly. This is domain means this is called codomain, but here A, B, C is there, output x, y is set. The constant means on particular term, okay? A, B, C equating only the y, that is the constant of the term y, okay? So how to make it the form actually, the constant function. So x related to y means definitely modulus x divided by x. If it example modulus x divided by x means, so x value considered for 1 means definitely what the answer will come? X is equal to 1 means modulus of 1 divided by 1. Modulus of 1 means 1 will come, 1 divided by 1 also 1 will come. Therefore in your graph also definitely one constant value, isn't it? The constant equating each and every answer, take it 1 means definitely, if it example, okay, 3 take it means what will happen? X is equal to 3, the same function modulus x by x, x considered for 3 is there means definitely modulus of 3 by 3. So modulus of 3 means 3 by cancel also 1 will come. Therefore modulus of x of the term, this is x and y means one constant term will come. This is called definitely y is equal to the t. C means that is what is the name? Constant. Y is equal to C. So y is equal to C. C means what is the meaning? Constant. Okay. This is a constant. This is for first term. This is for the second, the constant term explanation. So the main term, what is the meaning? Modulus x divided by x, whatever the number. Even if you take 10 also, modulus 10 divided by 10 means 10 divided by 10 also cancel value will be 1. That's why we are saying this is called the x-axis, this is called y-axis, means constant term will come, y is equal to c. That is constant function. Okay, moving to third one. So third one, I think modulus or absolute value. So yeah, modulus function or absolute value function, one of the important, okay, modulus and absolute value function, or absolute, I think modulus or absolute, okay, not and, okay, modulus or absolute value function, absolute value function, okay. Modulus or absolute value function means what will happen? Take one number line. So one number line means 0, positive 1, true 3, 1, true 3. The negative 1, negative 2 and negative 3. This is negative side means this is positive side, isn't it? If it example modulus, no? Modulus of negative 3 means what will happen? So modulus of negative 3 means positive 3 will come, isn't it? So that's why in your book given 3 different ways at one function. If it example modulus x, we can write it minus x if x belongs to less than 0 means. At the same time 0 when if x is equal to 0. So positive x means if x greater than 0, or the same function we can write it modulus x is equal to minus x if x greater than or equal to minus x, no, less than or equal to 0, less than or equal to 0. So positive x if x greater than 0, or the same function modulus x, we have output, 2 different output, minus x if x less than 0, at the same time positive x when if x greater than or equal to 0. We can write it in 3 different ways. This is a different number 1, different 2, different 3. 3 different ways we can write it, okay. This is called modulus. So what is the meaning of modulus actually? If it example modulus of minus 5 is there means answer definitely plus or minus, okay. If it positive 5 means, if you remove the modulus means definitely plus or minus 5 will come. That is called modulus of the term, okay. So how to draw in the graph actually? So how to draw the graph actually? So if it example y is equal to modulus x, okay, for example y is equal to modulus x. So y is equal to modulus x. So x is equal to value positive 1. What will happen? Okay, y is equal to positive 1 means definitely output 1 will come. Therefore where we have 1 comma 1. At the same time instead of positive 1, x is equal to minus 1. What will happen? Y is equal to modulus of minus 1. Modulus of minus 1 means y is equal to positive. If you remove the modulus means the negative value also should become a positive, okay. So therefore now another one pair minus 1 comma positive 1 is there. Therefore if you take it the positive axis means definitely we can say this is called positive side will come, isn't it? Y is equal to x. At the same time negative sign means y is equal to negative x. This is the term of absolute or modulus value function, okay. I am moving to next one. So next one in your book, greatest integer function, isn't it? So greatest integer function, another one name greatest integer means or floor function, isn't it? So greatest integer or floor function, the maximum we are using the word actually greatest integer, okay, not in floor. So just keep in your mind, okay, floor another one name of greatest integer function. So greatest integer function, the symbol we are doing like that, this is a symbol, okay. At the same time I am writing smallest integer function, okay. So smallest integer function, okay. The smallest integer function means upper, okay, uppercase. This is another one name or cell function, okay, cell function, okay. The smallest integer example 3.99 something means we have to select left side of the value. Left side means example one number line is there. This is 0, 1, 2, 3, 4. Okay, 1, 2, 3. Value we have 3.9 and something. Here means left side one of the less than value of the whole number. What the value is there? 3 is here. Therefore, 3.99 means value will be 3. At the same time, negative value. Okay. So, negative 3.5 is there. So, negative 3.5 means another one number line 0, minus 1, minus 2, minus 3 and minus 4 is there. Value minus 3.5. Center will come now. Center means the less than of the term minus 4 only. Well, therefore, minus 3.5 greatest integer function value we have minus 4. Okay, what is the meaning of smallest integer function? Greatest integer we have consider for the left side of the term, but smallest integer we have to consider for right side of the value. For example, 1.25 is there. Okay, one number line is there. So 0, 1, true, 0, 1 and true. Value we have 1.25. Here means the whole number right side of the term. The value we have true. Okay. At the same time, so minus of the value. So minus 0.5. So minus 0.5 means definitely one number line is there. So this is 0 means this is minus 1 in between. So minus 0.5 isn't it? So minus 0.5 means here will come now. Minus, but right side 0 only is there. Therefore, answer we have 0. Okay, this is the right side. This is called left side. Greatest integer function means. Okay, so another one, Zenum function. Zenum function. Actually, G is a silent word. Okay, Zenum function. The term we can write it in two different ways. So, x divided by modulus x. If x not equal to 0, x value 0 means definitely x is equal to 0. This is one of the condition. Okay. So, x divided by modulus x, example. So, x consider for 3 is there means definitely 3 divided by modulus 3 means value we have 1 will come, isn't it? Because 3 divided by 3 means 1. At the same time, if it positive 3 is there, if you take it negative 3 means what will happen? Negative 3 means x divided by modulus x. So, x divided by modulus x. X consider for negative 3 means negative 3 by modulus of negative 3. Therefore, negative 3 divided by, if you remove the modulus means positive 3 no. Therefore, negative 3 divided by positive 3 means negative 1 will come. Sign will be different. If you take the positive value also, we will get the result negative. Sorry my dear, take the value positive means output also positive. But if we take x is equal to negative means output also we have negative. That is the difference between x divided by modulus x. But x is equal to 0 means definitely when you can say 0, if x is equal to 0 means therefore output we have 1, 0, minus 1. This is the value between minus 1 to minus 1. Okay, this is called the Zenum function. Okay, I will continue the next function. Okay, be stay on the line. So, I am moving to type of function. Okay, type number 1, one-to-one function. One of the important topic. So, first one-to-one function. What is the definition for? This is definition. Okay, definition for one-to-one. Different elements of A have different images in B. So, already you know what is the meaning of function. All elements on A are associated to some elements in B. But in one-to-one function, different elements of A. Okay, consider for. So, A, this is B means, this is domain means B is called codomain. So, different element means consider for A, B, C. Different images consider for 1, 2, 3 and 4 means A related to 1, B related to C related to 3. So, each and every pair only single pair. So, 1 to 1 comparing A related to 1. So, B related to 2, C related to 3. At the same time, A, B, C, 1, 2, 3, 4. A related to 2 means B related to 1, C related to 3. This is also related to 1 to 1 only. So, this is we can say this is a both the term consider for 1 to 1. So, how to consider for your more understanding, look at there. I have taken for one parabola. Okay, open upward parabola. So open upward parabola. This is considered for, this is 1, this is true means this is considered for -1 means just I will equating, okay, for your understanding clearly, then only you will get a clear idea. This is images, just move on like that, okay, this is the way. Okay, now this is 1 2 means just intersecting one line, okay, this is the line, it's considered for -1 means, okay, this is whole term 1 and 2 means this is 1, therefore axis we can say no, x is equal to 2 means y1, then -1, here also 1 is there, isn't it, this is -1 comma 1, therefore what are the relation we have, -1 comma 1, at the same time this is 2 comma 1, isn't it, then this is how to make it the pair. So now look at there, this is A means this is B, A is called domain means B is called codomain, A is equal to what are the value, -1 and true, so -1 and true, but B is common, no, 1 and 1 is there, isn't it, so I will write it 1 and true, but -1 to 1, isn't it, so -1 also 1, at the same time 2 also 1. So already we know it is a function, surely we can say, because child and mother means 2 child possible known, so 1 mother, but it is a function, but it is not a 1 to 1. Why? What is the meaning of 1 to 1? Different elements. So here different elements is there, but we are not getting different images. -1 not equating true, as well as 2 also not equating true. So different elements we are not getting different images. That's why it is not 1 to 1 function. So when you can say it is a 1 to 1 function, I have taken for x and y, okay, here one time parabola shape is there, so I will consider for one line, here more than one intersecting, isn't it, here also intersecting, here also intersecting, here also intersecting, but here only one intersect, this is considered for 2 means this is 1, this is 2 means definitely this is what is the meaning, 2 comma 2 only is there. If you make it domain and codomain also, only true only equating true, therefore this is simply we can say this is communicating only 1 to 1 number, therefore this is we can say. So what I am saying from this true diagram, intersecting more than 1 means definitely we can say it is not 1 to 1, but it is a function. So when you have intersecting only one point means that is called 1 to 1 function, okay. I will continue the next step. I am moving to second type of function. Second type, what is the name? Onto function. First one, 1 to 1 function, that is another one name injective, but onto function another one name surjective, okay. Surjective, that is what is the definition, the main, each element of B has its pre-image, okay. So pre-image in A. So example, make it do diagram. This is considered for A, B, C and D means this is called A. Domain means this is called codomain, 1, 2, 3 and 4. So mapping A to 1, B to 2, C to 3 and D to 4 means, so definitely we can say it is onto function. Why? So number of range, this is number of range is equal to number of codomain. Example, this is how to make the term. So A is equal to, what are the set is there? So A, B, C and D. At the same time B is equal to, what are the value? 1, 2, 3 and 4 is there. So definitely this is the codomain. So number of codomain is equal to number of pre-image. Number of pre-image means each and every element, this is image means this is called pre-image. Each and every image, look at there, 1 to mapping to A, 2 to mapping to B, 3 to mapping to C, 4 to mapping to D. Therefore definitely we can say the number of pre-image, otherwise number of range is equal to Number of range is equal to number of codomain. But instead of this diagram, suppose A is equal to A, B, C and D is there. Then B is equal to 1, 2, 3, 4 and 5 is there. If you are making the diagram, so A, B, C and D, 1, 2, 3, 4 and 5 is there. This is a domain, means this is called the codomain. Mapping A to 1, mapping B to 2, mapping C to 3, mapping D to 4. So definitely we can say it is not onto function. Why? Number of range, listen very carefully, number of range not equal, isn't it? Because number of range here 5 is there, not equal to number of codomain, isn't it? So codomain means B value. So each and pre-image, this is image means this is called a pre-image. See, so ABCD fill up is there, we have 5 balances there. Therefore number of range not equal to number of codomain. Suppose 5 is not available, means we can suppose 5 is not available in the element. So number of range only, number of range is equal to only we have the element 1, 2, 3, 4 means we can say definitely number of range is equal to number of codomain. Then only we can say it is onto function. That is the difference between not onto and onto. Here how to make it the pre-image part. So F inverse of 1. F inverse of 1 is equal to what the value is there? A. At the same time F inverse of 2 is equal to mapping to value B. Then F inverse of 3 is equal to mapping to value C. Then F inverse of 4 is equal to mapping the value D. This is we have to make it, okay. Then another one important example. Suppose A and B. So A we have A, B, C, but codomain only 1 and 2 is there. This is example, this is child means this is parent. Already we know a parent have 2 children is possible, but a child cannot possible to have 2 mother, isn't it? Therefore, mapping A to 1 at the same time B mapping to 2 at the same time C also mapping to 2. Possible no? So 2 child have 1 parent is possible. That's why this is example. This domain consider for child, B codomain consider for parent means 1 parent possible to have 2 children is there. Therefore, how to make it? So it is onto function. Therefore, F inverse of 1 is equal to mapping to A only. At the same time, F inverse of 2 is equal to B and C. So this is the example. Okay, I will continue another one type. Okay. So moving to another one type of function, that is one to one and onto function. Both of mixed means that is called bijective. So that is called bijective. Already I told you one to one, another one name injective. On to one, another one name surjective. So one to one and on to one merge means that is called bijective. So a function, what is the definition? A function which is both one to one and on to means that is called bijective. For example, make it one arrow diagram. This is called A, B, C and D, 1, 2, 3 and 4. So mapping A to 1, mapping B to 2, mapping C to 3, mapping D to 4. This is the domain means this is called codomain. So definitely first we can check it. It is one to one. What is the definition for one to one? A different element of A has different images in B. Each and every one we have the different element, no? Different element to equating for different images. That's why we can say it is one to one. Then on to one means definitely we can say no. On to one also, what is the meaning? A function is related to number of codomain. That is number of range is equal to number of codomain. So number of element, if it example B is equal to what are the element is there? 1, 2, 3, 4 is there. So number of range is equal to number of element in B. It will be equal, no? Therefore we can say it is on to one also. So a function which is both one to one and on to its equal means we can say It is bijective. It is bijective. So when you can say it is not bijective, listen, another one arrow diagram. So A, B, C and D, only 1, true and 3 is there. So mapping A to 1, mapping B to true, mapping C to 3, at the same time mapping D also 3 only. So definitely we can say it is not 1 to Y. So already you know definition for 1-to-1 function means different element have images in different images. But here true different element have images in same. So true different element have same images. That's why we can say it is not onto. But whether it is onto, yeah, sure, no, it is onto, no. Therefore, how to make it pre-image? F inverse of 1 is equal to A, then F inverse of true is equal to B, at the same time F inverse of 3 is equal to C and D. We can say it is onto. But anyone not equal means we can say it is not bijective. It is not bijective. Then another one example. So A, B, C and D, 1, true, 3, 4 and 5 is there. So mapping A to 1, mapping B to true, mapping C to 3, mapping D to 4. So listen, first we can say it is 1-to-1 because the different element have different images. This is A means this is called B. So 1-to-1, but it is onto, not onto. Why? Definitely we can say number of range is not equal to number of element in B. So number of element B we have 5 terms there, but range only 4 only is equating. That's why we can say it is 1-to-1 but not onto. Therefore, it is not bijective. Okay. So please listen, my dear students. Almost a concept is over regarding the function. Okay. So if you have any doubt, please put in comment box. I am ready to clarify your doubts. Okay. I will continue the next session. Bye bye.